Good morning, class, and welcome to today. Today we're going to discuss how to solve equations when we have variables on both sides of the equation. And so I've written a little cheer for us to help us remember. That does not necessarily mean that we always have to do it this way, but it does help us stay organized. So I'll give you my best effort here. Variables to the left, numbers to the right. Stand up, sit down, fight, team, fight. Go Lions. All right, and then we just give some spirit fingers. And what that's going to help you do is remember this. You want to get the variables when solving a multi-step equation where you have variables and numbers on both sides. You want to get the variables to one side and the numbers to the other. So let's just look at our rules. Again, solving an equation with variables on each side. To solve an equation with the same variable on each side, we first use the addition or subtraction property of equality to write an equivalent equation. If you have grouping symbols, we need to remember to use the distributive property. So let me go ahead and solve this first example with you. It is in your notes, example 1, but I'm going to solve it for you step by step, and then I'm going to give you 3 additional problems as well. Does that sound good this morning? Okay, so here we go. Example number 1. And then after I do example number 1, we're going to get you guys to give a cheer this morning. Wow. Okay. Example 1. (5y minus 8) equals 3y plus 12. According to our cheer, the directions that I've given you above, we would like to move the variables to the left side. So we are going to subtract 3y from each side of the equation. And when we do, we have 2y minus 8 equals 12. So the variables have now been moved to the left. What should I do next? Who knows? Thank you. I know who you are. Yes, right here in the back. Add 8 to both sides. And I get 2y equals 20. Who can solve it from there? Thank you.
Y equals 10.
Divide each side by 2. Y equals 10. Does anybody have a good suggestion? What should I do at this point? Yes, right here. Check your work. So we're going to go 5 times 10 minus 8 equals 3 times 10 plus 12. Or 50 minus 8 equals 30 plus 12. Or 42 equals 42. Sorry, let me just fix that. So we have solved the problem correctly. Does anyone have an example, a question on example 1? Are you sure? So example 2, I want you to put this in your notes. Example number 2. Example 2 is going to be using grouping symbols. So let's see what happens when we use some grouping symbols. So this is your original equation. Original equation. And it's in your notes. I'm just getting rid of some of this stuff here so I have a little bit more room. There we go. So 5x plus 5 equals 3 times the quantity 5x minus 4, end parentheses, minus 10x. Step number 2, let's simplify the right side. Sound good? Let's just change the color here to make it brighter. So we have a little. So this stays 5x plus 5 equals 3 times 5x is what, class? Minus 3 times 4 is minus 10x. So we want to simplify the right side, and we want to add like terms. Does anyone see any like terms on the right side? Yes. 15x minus 10x. So what we have here is 5x plus 5 equals, what's 15x minus 10x, guys? Equals 5x minus 12. Are you with me? So now we want to get the variables to the left side. So what are we going to do now? If you know, raise your hand. Variables to the left. Yes?
Cancel out the 5x.
Subtract 5x from each side. And I'm left with 5 equals negative 12. So I'm just going to write a little question here for you guys to think about. So my question is, what kind of a statement is this? 5 equals negative 12. Is that a true statement or a false statement? It's a false statement. Whenever you have a false statement where the left side and the right side make absolutely no sense. First of all, let me just go on record as saying 5 will never equal negative 12, no matter how hard you try or I try. So, when you have a false statement, your answer is no solution. And you could write no solution, or you could write the empty set. Are you with me? Yes? So this is an example using grouping symbols, and it is a no solution. So let's just review one more time. You solve the whole problem. You get to the last step, and you have 2 different things on each side, and there's no way that 5 could equal negative 12. If you get something like 0 equals 6 or 10 equals negative 1, your answer every single time, you're not going to put false, but you're going to put what, class? No solution. Does anyone have a question on this? Okay. And then the last example that I'd like to share with you today, before I let you guys do a couple of problems, is called all solutions, or we also refer to it as an identity. And it's called an identity because it's almost like identical twins. What you see on both sides of the equation are exactly the same. So here we go. 3 times the quantity, 2b minus 1 minus 7 equals 6b minus 10. So this is my original equation. Yes? Y'all with me? All right, let's just brighten it up a little. Okay, so we're going to simplify the left. We're going to use the distributive property and simplify the left. So here we go. 3 times 2b is what, class? 6b minus 3 times 1 is 3 minus 7. So now we want to add like terms. What's a minus 3 minus 7? What does that become? 6b minus 10 equals 6b minus 10. Now, some of you might realize right here in this step that when you're looking, you see the same exact thing or identical twins on both sides of the equation. If you see it there, you can answer it and say identity or all solutions. Or we could take it one step further. To take it one step further, we want to subtract 6b from each side. And you're left with negative 10 equals negative 10. And so I ask you the same question I asked you in the previous problem. What kind of a statement is this? Is this statement true or false? True. Did you have a question? No. Okay, it's a true statement. So when you have a true statement, your answer is all solutions for identity. Yes, question.
When we write it on our answer column, would we write numbers and
No. What's the answer? When you have a true statement, your answer is either all solutions or identity. Okay? That's not the answer. The answer is when the left side and the right side equal each other, your answer is all solutions or an identity. Okay? One more time, let's go over it. 3 times the quantity 2b minus 1 minus 7 equals 6b minus 10. That's my original equation. I am going to use the distributive property and simplify the left. 3 times 2b is 6b. 3 times a minus 1 is a minus 3, minus 7. Minus 3 minus 7 are like terms, which gives me a 6b minus 10, which equals, on the other side, a 6b minus 10. Remember, when solving equations with variables on numbers on both sides, we're going to move the variables to the left. So when we subtract 6b from each side, we get negative 10 equals negative 10, which is a true statement. When your answer is true, when the left and the right side are identical, the answer you would put in your answer column is all solutions, identity, and some math authors also use this term, many solutions. I would prefer all solutions or identity. Are there any questions? Okay, so let's go back one more time and look at the previous example. So there's 3 scenarios here, basically. You solve a multi-step equation with variables and numbers on both sides, and you get all the way down to the last step, and you actually solve and find a number for the variable. You plug it back in and check your work. You've solved your equation correctly. The other scenario is you have an equation with variables and numbers on both sides. And let's look at this one more time. 5x plus 5 equals 3 times the quantity 5x minus 4 minus 10x. That's your original equation. We simplify the right side by using the distributive property and then adding like terms. 3 times 5x is 15x minus 3 times 4 is 12 minus 10x. 15x and 10x are like terms. 15x minus 10x gives me 5x. Now at this point right here, I have 5x plus 5 equals 5x minus 12. Variables to the left, numbers to the right. Stand up, sit down, fight, team, fight. Go Lions. So I subtract 5x from each side, and I get 5 equals negative 12. Now remember, I told you, when you get a ridiculous statement like this, 5 equals negative 12, what kind of a statement is it? You know that 5 can never equal negative 12. That's a stupid statement. It's false. And your answer is no solution. Are you with me? Yes? Anybody have a question? All right, let's try our cheer. I do want to make sure that everybody has the homework packet. Yes? Okay, thank you. So now everybody has one. So let's look at the homework packet, please. real quickly. And let's look at our cheer. So your homework tonight, remember what I told you. We are not using the homework packet I previously gave you. For these next few lessons, we're using this. And it says, Algebra and Honors Homework, Mrs. Urso and Mrs. Raines, Lessons 2-4 through 2-7. So I told you what to do with that other packet. Put it somewhere in the back of your book. Now, if you are absent today and listening to the recording, please call a friend and ask them to take a picture of the page and send it to you. The homework is on RenWeb. Tonight's homework is this practice page, 2.4, 1 through 21 odd, 22, 23, and 24. Do not do work on here. That way, if you ever have to send a copy of the page to a friend, your answers and no work is on here. All work on notebook paper. Okay? How about if we try number 1 together? Let's do one of your homework problems. But first, I'll see if I have any cheerleaders in here. Everybody, get up out of your seat. Let's do our cheer one time. One time. You're going to watch me. I'm going to face the screen because we're going to use some arm movements as well. Hands on your hips. 5, 6, 7, 8. Variables to the left. Numbers to the right. Stand up. Sit down, fight, team, fight. Go Lions. Okay, here we go. Let's do it again. You ready? 5, 6, 7, 8. Variables to the left. Numbers to the right. Stand up, sit down, fight, team, fight. Go Lions. Okay, great job. Give yourselves a hand. That concludes our lesson for today. I hope that if you weren't here, that you do the cheer on your own.